Hi, Mr. T here with a tutorial on Introduction to Matrices. This is a new topic for us in algebra, and before we get into applications of matrices, we need to define what they are and talk about how we can do operations with them. They're a fairly simple concept. Matrices are a rectangular arrangement of data, or another way to think of it, it's a table of data, but we strip off our row and column headings. Some of the applications that matrices can be used for, the first one here we'll be using in our class in a couple days. We can use matrices to solve systems of linear equations. We've been solving them algebraically using substitution and linear combinations, but as we get to equations that have more than two variables, 3 variables or beyond, the methods that we are currently using are going to become quite difficult. But we can solve much more complex systems of equations using the matrices. We'll also do an activity in class where we do a simple graphics application. We will be storing the coordinate pairs, the x and y pairs for a picture, the vertices of a picture inside of a matrix. And using matrices we can rotate the picture, we can enlarge it, we can move it around the screen. So matrices are used in a lot of computer graphics applications. And in business they could be used for storing inventory data. They're also used for, say, routing of shipping for, say, trains or trucks. So they're used in transportation routing and lots of applications. So let's go ahead and talk about what matrices are. So let's talk about terminology and conventions. So the names for matrices, when we give them variable names, will be capital letters. So for example, we could have a matrix A, and we put the data in square brackets. So let's just I'm just going to make up random numbers here to put in my matrix. For now, the matrix does not have any particular meaning. They could be numbers, they can be all kinds of real numbers, they could also in certain situations be variables. So this is a matrix, this is matrix A. When we talk about matrices, we want to talk about their dimensions or size, and we talk about it in terms of the number of rows. So this matrix has 2 rows and it has 3 columns. So this is row 1 and row 2, and in our columns this is column 1, 2, and 3. And when we talk about matrices, we always put rows first by columns. Sometimes we will be writing the dimensions under a matrix if we're using it as some convention in some textbooks. So the dimension of matrix A, or the size, as I just said, is 2 by 3. Sometimes we want to refer to the individual items in a matrix. Those would be referred to as elements. And if this is capital matrix A, we would refer to the elements using lowercase. And we use 2 little subscripts. Actually, let me put it more descriptively. The first subscript is what row the element is in. And the second is the column. So if I put down here A sub 1, 3, that would be the item in row 1, the 3rd column. So that would equal -5. Let's say A 2 would be row 2, column 2 would be -1. And again, these are referred to as elements of the matrix. So we have our dimensions, rows and columns, capital letters for names of matrices, and many times in textbooks these capital letters will be in bold, but I'm not going to take the time to make all these bold, so we'll just use capital letters for our matrices. We have square brackets and rows and columns. So that's our terminology. So let's move ahead. Now there are some terminology for some special matrices. So sometimes we might have what's called a row matrix. That would be a matrix of numbers in one row. So we might have a row of numbers here. So that's a row matrix. Likewise for column, the numbers would be in columns. When we do our graphics application, we'll be using column matrices. So we would have, this might represent the point 3, 2. X is 3, Y is 2. Columns could be longer. Zero matrix is just a matrix of any size that is completely filled with zeros. A lot of the operations we're dealing with will require the matrix to be a square matrix, so that means the number of rows equals the number of columns. So we might have a, say, a 3 by 3 matrix. And finally, something we'll be using down the road a bit is something called the identity matrix. And that matrix is a square matrix, and it has ones down the diagonals. And I'm not going to fill all this in, but everything else, all the other elements, will be zeros. So we have ones down this diagonal. And again, it will be a square matrix. Now when we're dealing with matrices, we will be wanting to do mathematical operations on the matrices, so we need to talk about operations such as adding, subtracting, multiplying. So we'll be talking about those next. So let's start to talk about mathematical operations. We will also be talking about matrix equations. So we need to talk about what does it mean for two matrices to be equivalent or equal. So if we have matrix A equals matrix B, we know several things. We know that they have to be the same size or the same dimensions. And corresponding elements, being elements in the same position, have to be identical. So every row and column in matrix A for some number of I and J has to be equal to the same, that should be an I, and J in the other matrix. So for example, if we have matrix here, let's do 3, 2, -1, 0, and we're trying to see if that's equal here. Maybe this is 9/3, 4/2, -1 and 0/8. For these to be equal, every position pair has to be equal. So 3 and 9 divided by 3 is 3, so those are equal. Those are equal. These are equal, and here this is equal. So those two matrices would be equal. If we change this one item here, these are no longer equal. They have to be completely identical. We might have a problem where we are, oops, I went too far. Have something like 3x, 0, I'll make this simple, 1 and 2y equals 6, 0, 1, 8. So to make those equal, that's been an equal sign there, those zeros match, those ones match, so here 3x would need to be equal 6, so x has to be 2, and 2y must equal 8, and therefore y must equal 4. So the only way that those two matrices would be equal is under the conditions that those x and y have those values. So let's talk now about adding and subtracting matrices. So if we want to add matrix A to matrix B, or subtract, again, they must both be exactly the same dimensions, and we will add or subtract the corresponding elements. So if we are, let's say matrix A again was 1, 2, 3, 4, and we're adding that to matrix B, which is, let's say, -3, 1, 2, 6. In our answer, it's going to be the same size. It will be a 2 by 2 matrix, and in this element we've got 1 plus -3. In this element we have 2 plus 1. Here we've got 3 plus 2, again corresponding entries, and 4 plus 6. And then we would just compute those numbers. Most of us could do those in our head, so we had -2, 3, 5, and 10. And again, if this had been subtraction, then we would be subtracting all these items and get the appropriate numbers here. So this would have been 4, this would be 1, this would be 2 minus 1 is 1, and 4 minus 6 would be -2. Now when we had addition, I should, maybe I can back up here. Let's see. When we had this problem as addition, we are using regular integer or real number addition here, and each of these operations are commutative. So when we're talking about matrix operation, like in numbers, A plus B is the same as B plus A. So matrix addition is commutative. Understanding which operations are commutative makes it easier when we're solving equations, because it doesn't matter which order we solve. Operations which are not commutative are more challenging, because when we're solving equations we have to make sure that we maintain the order of the terms in an operation. And we'll be talking about that later when we do some more complex matrix operations. So that's equality and addition and subtraction. So let's talk about now multiplication. Now there are two kinds of multiplication for matrices. There's called scalar multiplication. Scalar means an individual number, or a single number, a constant, whatever you want to do it. So we might be, for example, doing 3a, where A is a matrix. That would be a scalar multiplication, and matrix multiplication is where we are multiplying two matrices together. Scalar multiplication is very simple. It's kind of like the distributive property. So if we're multiplying 3 times a matrix here, we would just multiply 3 times every item in the matrix. So 3 times -2 is -6. 3 times 1, 3 times 0, and 3 times 5. We'll talk about, when we do the graphics application, we'll talk about one of the applications for scalar multiplication. Now again, these examples I'm using, we've had fairly small matrices because I don't want to write them out, but this same thing would work if this matrix was 10 by 9, 90 numbers in here, then we would multiply all 90 numbers by the 3. Now, matrix multiplication, only certain matrices can be multiplied. So here we can multiply a scalar times any matrix. Here, there will be many matrices, depending on A and B, where we cannot do this multiplication, where it is not defined. And the rules are, if we look at the dimensions of matrix A, let's say it was m by n. To be able to multiply matrix B, it has to have n rows, and then it could have any number of columns. When we are multiplying and we put the dimensions side by side, in order for the multiplication to occur, the columns of matrix, the first matrix, and the rows of the second matrix must be the same. If those numbers are different, then we would write that this product is undefined. The second part is our result matrix, let's call it matrix C, its size will be the rows of the first number here, of the first matrix, so it'll have m rows, and it will have this number of columns, p columns. So our resulting matrix might be different than the size of all the other matrices. So for example, if we were multiplying two square matrices, let's say A was 3 by 3 and B was 3 by 3, we can multiply that. Whoops, that's supposed to be to there. Those are the same. And our resulting matrix would be a 3 by 3 matrix. Let's say A was 5 by 2 and B was 2 by 3. Again, those numbers match, and matrix C would be a bigger matrix that would be 5 by 3. If we look at this and reverse the order, let's say we're using these same two matrices and we tried to do B times A. So B was 2 by 3 and A was 5 by 2. Since those numbers are not the same, we cannot multiply, so this is undefined. We cannot do that operation. So in this case, we have AB equaling one thing and BA equaling something different, in this case undefined. Therefore, multiplication, matrix multiplication, is not commutative. Meaning our order of the matrices, which one's first and second, matters in terms of what the result. This is going to be very important when we again move ahead for application. So let's talk about, all we've talked about now is under what conditions can we multiply and what the size of the result is. Let's go through an example here to show how this is going to work. Matrix multiplication is fairly tedious, so we will be doing relatively small matrices when we do it by hand. And later in this tutorial, we'll talk about how we can use calculators, in particular graphing calculators, for doing matrix operations. So let's make here a matrix. Maybe let's make matrix let's make matrix A 2 by 3 matrix, and we'll make matrix B be let's say a 3 by 2 matrix. So when our result is going to be a 2 by 2 matrix. So let's make up a matrix A, a 2 by 3 matrix, so 2 rows and 3 columns. I'm keeping the numbers small here just to make the multiplication easy. That's matrix A. And matrix B is 3 rows and 2 columns. So let's make it just easy. 1, 2, 3, 4, 5, 6. And we're multiplying those together. And we know our result is going to be, in this case, a square matrix. That's 2 by 2. Now, one way I keep track of this when I'm doing it manually, you'll see in a minute, but I'm going to label each of these elements by their subscripts. So this would be row 1, column 1. This is row 1, column 2, and row 2, column 1, and row 2, column 2. When we multiply matrices, we are going to go by rows on the first matrix and columns on the second matrix. So when we are multiplying or trying to get this here, we're going to use row 1 from the first matrix and column 1. So let me highlight what we're using here. So we're going to use here row 1 times column 1. And the way the multiplication works, okay, somebody picked up the phone, so let's keep going. So the way this works is we're going to multiply the first item here by the first item here, so we have 1 times 1. So we have, I'm going to write it out here so you can see 1 times 1, and then plus negative 1 times 3, and 3 times 5. I didn't really leave myself enough room. Now we would multiply that out, so we've got 1, and then here we have negative 1 times 3 is negative 3, and 3 times 5 is 15. and we add those together, so we get negative 2 plus 5. We get, in this first spot, we've got the number 13. Now let's move over and do here. So we're still using our first row, but now we are multiplying it times the second column. So we're going to go this way and this way. So now we're doing 1 times 2 is 2. Negative 1 times 4 is negative 4. And 3 times 6 is 18. So we've got here negative 2 plus 18 is 16. Now we got to go down to here. So now we're using the second row and the first column. So let me move our highlights. So second row now and back to the first column. So 2 times 1 is 2. 0 times 3 is 0. And 1 times 5 is 5. So we have 7. And finally, we're doing row 2, column 2. So we have 2 times 2 is 4. 0 times 4 is 0. And 1 times 6 is 6. So we have 10. So you can see by the way this multiplication works, we can see why we need to have the same number of columns in the first matrix as we have rows in the second matrix, because we're multiplying across. So we've got 3 columns across here, so we have to have 3 rows here. That's why those two numbers have to be the same. If those numbers weren't the same, you could see that the numbers wouldn't match up and we wouldn't know what to do. So this is our result. So let's talk about now, we've seen how to do all these basic operations by hand. So let's talk about how we can do these using a graphing calculator. So let me bring in my graphing calculator. Let me turn it on and let's clear it. So first we're going to talk about inputting matrices, and for the examples we're going to do with the calculator here, we're going to use these 3 matrices. So first what we might want to do is I'm going to talk about deleting matrices. So to see what matrices we have, we press second and the plus key here from memory, and we go to memory management, item 2, and go to item 5, matrices. So if we had matrices, they would be listed here, and if we wanted to get rid of them, we could press the delete key on each one to delete it. So my calculator is clear, so we don't have any matrices. To input a matrix, we're going to use the matrix menu, which is here in yellow, so second matrix. And we have 3 menus. We have names menu, which we use to pull out matrices when we want to operate on them. Math, which we'll talk about it in another lesson, and edit. So when we're inputting a matrix, we're editing. So I need to move over to edit, and let's edit matrix 1. So we're going to input matrix 1. I first have to input my dimensions so it knows how big it is. So I put over here matrix A as a 3 by 4. And we hit enter, and we're going to input the numbers. As we hit the enter key, we're going to go across in rows. So I'm going to enter 3, 2, negative 1, 0, negative 5. You'll see it scrolls over as we move across. Negative, 0.5, and negative 3. Now we're on our last row, 1, 4, negative 7, and 8. And enter that last number. So now, just to make sure I don't mess up, I'm going to do second quit and get out of there, but now I'm going to go right back in and enter my matrix B. Frequently when we're doing matrices, we'll enter all the matrices that we're going to use first, and then do the operation. So matrix 2, we want to edit. It's also a 3 by 4. And whoops, I hit 34, so let me back that up. So 3 by 4. And I'm going to pause the video here and enter this data, and I'll be back with you in a second. So now we can see the data is in here, so I'm going to again press second quit, and I'm going to go back into my matrix and edit and enter matrix C, which is matrix 3, which is a 4 by 2. And again, I'm going to pause for a second. You'll see the data when I come back. All right, so now we're back and we have the data here. And so I'm going to get out of my matrix. So now we want to do calculations. So let's say I want to add these two matrices. Now they're the same size, so I can add. So I have to first pull up matrix A. So that's where we're going to use the name menu. Second matrix, and I want to pull out matrix 1. So it shows the letter in brackets. That means it's a matrix. Now we're going to multiply that times, we're adding here, sorry. We're going to add that times matrix B. So second matrix B, which is number 2. Hit enter. Now you can see here the matrix doesn't fit completely on the screen. When we have dot 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 here, it means we to the right to see that we can scroll over to see all the items. Each row is in a bracket, and then the entire matrix is in a bracket when we do this on the calculator. So that's A plus B. Let's do A minus B. So we could type this back in, or I can use my second enter key to bring up the last operation, and then I'm going to edit that line by making that a minus, and now I can press enter. So now we've subtracted the two matrices, so we've taken every element in matrix A minus matrix B all the way through, and the calculator is doing that for you really quickly. Let's try A plus C. Now you should know from earlier A and C are different dimensions, so if we add those up we're going to get it shouldn't work. So let's see what the calculator does. Second matrix A and plus matrix C. Now that shouldn't work, so let's see what kind of message we get. And we get dimension, that stands for dimension mismatch. So it's telling you that we can't add the two matrices because they don't have the same dimensions, which is what we would expect. Let's look at a scalar multiplication. Now remember, when we do this operation here, it's going to multiply every item in matrix A by -3. So let me clear this out. So let's do -3 times. Now we can hit the times, or we can just put it next to the matrix, either way. So I'll show it this way this time, and we hit enter. And notice each of these items, if we just look at the first column, are 3 times. Now this is not changing matrix A. Matrix A stays the same. We could, if we needed to, store this matrix in this result into another matrix if we wanted to use it. Normally we'll just keep it on the screen. I'm going to skip this one. You would just type in 2 matrix A plus 3 matrix B. So let's look at multiplication to end this up. So let's go to A times C. Now if we look at here, A times C, A is 3 by 4 and C is a 4 by 2. So those match. That's good. So we should be getting a 3 by 2 matrix as our result. So let's see if that happens. So second matrix A times, and we can just put it back to back if we want, or we can hit the times key, matrix C, which is 3. And you can see here we're getting a whoops, what did it, we should be getting 3 by 2. What am I doing wrong here? We're getting, oh that's right, I spazzed out here. We got 3 rows, 1, 2, 3 rows, and 2 columns. So we got exactly what we expected. Now if we try C times A, C is 4 by 2, 3 by 4. Notice this does not check out, so this should not work. Let's see what kind of error message we get. Second matrix C and second matrix A. And again, we get dimension mismatch, saying that the dimensions, it's not that they're not equal, but they're not appropriate for multiplication. Let me go back now that we have some matrices. If we wanted to clear out these matrices, we would again go to second memory to get into memory management. So we go to item 2. We go to matrices, and it's pointing to here. If we want to delete that one, we can press delete. If, say, we wanted to keep B, we could move down here and delete C if maybe we're going to use C again. So if we go back to our matrix menu, matrix B is still here, and we've deleted matrix A. So we'll be using, for a lot of the more complicated problems we'll be using the graphing calculator for doing our operations. You should know how to do simple operations, adding, subtracting, multiplying on small matrices by hand, and we'll be practicing that in class. So have a great day.